Okay, are the triangles at the right similar? All of the similarity theorems are on page 120 of the book, but I hope to have them up on the wall for the test. So which two triangles are we looking at? Here and here. And I know these pictures didn't come out very well, so let's take a look at these numbers. This was 4, 7, 9, and this side is 14. So obviously these two angles are the same. So the line between these two angles should correspond to the same line between those two angles. And then ES should correspond to NK or whatever it is, because those are between the same angles. So remember, one of the ways that questions like to trick you is by putting the sides of the triangles in a different order. All right, so first it says determine the perimeter of TES. So that's just 4 plus 7 plus 9, which is 7, 8, 9, 10, 19, 20, right? 9, 10, 11, 12, 20. So that is 20. And it says using a proportion. Oh, I forgot to determine. Are that justify your conclusions completely. So let's go back to A. I'm sorry, you guys. So I like to do those tables. Remember where we talked about we have a claim and we have evidence, but you could also use a flowchart. Okay, claims and evidence. So what are some things I know? I know that angle T is congruent to angle A because that is given. My evidence is that it's given in the problem. It tells me that, right? T has that one, A has this one. So the same thing you could say for angle S is congruent. My claim, is congruent to angle K. Let's call that K. Oh wait, ANF. I guess that's F. And I know that because I looked here. And that is also given. Okay. And so I have, so that's enough, right? If they're similar, that means that triangle TES is similar. That's just the one angle, the one wiggly line is similar to triangle. Let's see, if I did TE first, then I need to do F and, nope, TE would be A and F. Remember, they have to be in the right order, A and F, because of angle-angle similarity theorem. Remember, if two angles are the same in a triangle, then all three are, and the triangles must be similar. So that's the justification piece. The perimeter of TES is 20. Now, because they are similar, we know that all of their sides must be proportional. And that also means that their whole perimeter is proportional. So if I know that I only have to do this once, if I know that 4 over 14 is proportional to 20 over the perimeter of the other one, which we will call x. So we can cross multiply here. So I got the 4, this 4 matches this 14. That's how I set up the first fraction. And then this perimeter over here was 20, and I want to know the perimeter of this one, so that's where the x came in. So now I just have to cross multiply. So 4 times x is 4x is equal to 20 times 14 would be what? 380. I'm just going to check this. If I have a calculator, I might as well check. What is 14 times 20? 280. Yeah. 280. And then divide both sides by 4. So x is equal to 70. Okay, what does X stand for? What was I actually looking for? The perimeter of the second triangle. So the perimeter is equal to 70. You could have done it. You could have done this if you do not like the idea of cross multiplying. Remember, if you have proportional fractions that, and it looks like this is going to be pretty, because 4 times what is 20? 4 times 5 is 20, so if I multiply the denominator by 5, I get, well, I mean, hopefully I should get 70. 5 times 4 is 20, carry your 2, 5, 6, 7, yep, 70. Either way you wanted to do that. Sometimes it's not a perfect number like this and it doesn't work out as nicely. I happen to notice that 4 was a factor of 20, so I know 4 times 5 would be 20, so I knew it would work out pretty easily. Like I said, I hope to have posters up for all the similarities and all the congruences, because you will have to, on the test, you will have to do a proof, which means doing claims and evidence, whether you do it as a table like I like to do it or you do it as a flowchart, that's up to you. All right, what's next? Plot ABC with vertices -2, -1. So that's right here. So that is A. B is -1, +2. So that's B. And C is 2 and 1. So that is C. So we have this triangle right here. Cool. Create a new image, enlarging the original figure from the origin by a factor of 2. So that means I take each point and I'm going to multiply the x. So A prime, I'm going to multiply both by 2. A prime is going to be -4 and -2. B prime is going to be -2 and +4. And C prime is going to be +4 and +2, right? And so I can enlarge and I can change each of these. Let's pick a new color. Red, how about, so we really know the difference. So A prime -4, -2. There's A prime. And this only works about the origin, being able to do this, right? So it has to say from the origin to make this work, okay? B is -2, +4. 1, 2, 3, 4. So he's B prime. And C is 4, 2. Okay, so it looks like I don't know if those go directly like on that line. I can't really tell. Let's see. Over 2 up 1, over 2 up 1. Yeah, I think that does actually cross right over the other line there. And then here. Okay. Where are we on time? Oh, I can keep going. In the diagram below, there are 2 congruent triangles. What are they? Use a flowchart. Oh, good. Another proof. Another proof. So the triangles that they're looking at, it took me a second to figure out which triangles they were. So don't feel bad if you did, or feel really good if you did, and you can make fun of me. So there's one, right? We'll call that no, eraser's stupid. So we call this, we have this yellow triangle as one triangle, and if we make the other triangle blue, then where they cross over will be green. So here's the 2 triangles we're looking at, and are they congruent? So remember, the theorems for congruency are sometimes a little different than the theorems that we use for similarity. But what we have here, we have a claim and evidence. Okay. I'm just going to start off with what we know, that angle G and angle E is congruent to angle E. That is given. Cool. We know that angle A and angle D congruent to angle D given. Okay, and let's just go with what else we know. We know that from A to B and from C to D, so AB is a line, is congruent to CD, also given. And I know that BC is congruent. BC is congruent to BC, duh, it's the same line. And remember, what do we call that when it's the same line? We call that reflexive property. Cool. And what that means is AC, AC is actually congruent to BD because BC plus AB is the same and BC plus CD has to be the same amount, right? So from here, if this is the same and this is the same, then that must be equal to this and this one. So we'll call that, because they add up to be the same number, so adding to be the same number. Right? And then that does mean that we have two angles and a side. But the question is, you guys, the question is, remember, we have some things. We have two angles and a side. That could be angle, side, angle. Could be angle, angle, side, or side, angle, angle. But those two things are the same. So which one is it? Is the side between the two angles that we know? If that was true, we'd be talking about this side, but it's not. What's true is it's angle, angle, side, because it's first one angle, then the other angle, and then the side. So the two triangles, triangle GAC is congruent to triangle, and we have to do it in the same order. And now I need to erase this because I can't see. Oh, E, D, B, EDB, because of angle, angle, side. Okay, I'm going to stop here.